just to lay the groundwork, what's really different about these standards versus what we currently have in our states is that the true integration of three dimensions of science learning, one of those being the disciplinary core ideas, which is what everybody's used to, the other being science and engineering practice. You don't have to go yet. Science and engineering practices that is, in the old days, we call that inquiry, but science and engineering practices is actually taking inquiry and unpacking that to be much more specific, and in particular highlighting the areas of engineering. And then to take cross-cutting concepts, which are the connective tissue between various science content areas, and trying to move away from teaching science just in pieces of knowledge or in silos, but actually to take that to a more comprehensive view of how students really should be able to connect different ideas. So there's a much more central role of science and engineering practice than what we've had traditionally. And there is an expectation that students can connect what I call the story. You know, I kind of metaphorically talk about that adoption and implementation of these standards would mean that a student walks across the stage and gets a high school diploma and can metaphorically look back and see the story of science that unfolded from K to 12. And in that means that we have also developed these standards in terms of learning progressions, meaning that we have a finite set of core ideas that kids have to learn, but they are introduced at appropriate times and they build on one another rather than being separate and discrete facts, but actually something that builds toward an understanding by the time they graduate. Okay, you can go ahead. And actually, go ahead and click a few times. So this is a little bit of the history here. Back in the 1990s, we had two really top-notch documents that states have been using since that point to develop their own state standards. The National Science Education Standards, which came from the National Research Council, and the Benchmarks for Science Literacy, which came from the American Association for Advancement of Science. These two documents really form the basis of what, and really we could say all 50 states have been using to develop their standards. But it came with a cost. First of all, these two documents weren't developed to be adopted by states. They were developed to guide states. And I say that because states have to have specific learning outcomes for their students, because ultimately at the end of the day there's going to be some assessment, whether it be a classroom assessment or a state assessment, that assesses whether the students know this or not. And so as a former state science supervisor, I can tell you it was a challenge sometimes, because you had these two documents. The two documents represented two different facets of the scientific community, and so when you develop standards, you kind of chose from either book what would best suit your needs. And for the most part, they overlapped a great deal, but there were some things that were a little different in each one. And the other part is that they had a separate chapter on inquiry. And so, and as I'll show you in a few minutes, what that's tended to lead to is all states having a separate set of inquiry standards and a separate set of content standards, which tends to mean that they are taught separately and assessed separately, if assessed at all. And unfortunately, oftentimes what happens is they are not assessed at all. But you know, again, another real thing to point out here is that there were the two documents, which it really presented a bit of a challenge for us. Well, since then, there's been a lot of research done, a lot of it done through the National Research Council about how students learn. We know a lot more through cognitive science about when kids can learn various concepts and how well they can learn those at those different levels. And they help really redefine what learning was. That it's not just memorization of facts, it's actually being able to apply scientific knowledge and be able to apply it in new and unique situations. So fast forward to 2010. Oh, no, don't fast forward the slides. Yeah, thanks. The Carnegie Foundation Corporation in New York had a great vision and began to cultivate, through the opportunity equation, the idea that it's time for us to start thinking about science at a more national level. So there was a two-step process that was engaged. That the first step was to develop the framework for K-12 science education. This document brought together partners of National Research Council, American Association for Advancement of Science, National Science Teachers Association, and Achieve. And it really kind of unified the voice. Again, the reason I kept bringing up the two documents before is now states who have historically had a very difficult time with their science standards can truthfully say there's a document that is representative of the scientific community. So states who have traditionally dealt with the controversies or are chosen not to deal with the controversies, it gives them actually some authority and some legitimacy that the scientific community says, here are the things kids should learn between K and 12. But the other thing that this document does for us is it really lays out a vision for where science education needs to go in the future. And it really is a very different vision than what we have historically done. It really does bring those three dimensions I mentioned earlier together into a seamless and integrated view of how science works in the real world. So now we're in the throes of the second phase of developing the next generation science standards. We have a process that I wish I could get into the intricacies of. It's a pretty complex process, but what you need to know is that early on, 26 states signed on to be lead state partners. And to be clear, what that means is they were willing to have the chief, state school officer, the state board chair, sign a list of assurances that they would do such things as give serious consideration to adoption as presented. They would convene at their own cost large, broad-based committees to review confidential drafts and the public drafts of the standards. They would publicly announce they were part of the process, and they would engage around adoption discussions of how to best do this.